So we have a boat, which I'm going to draw down here. My boat looks like this. There it is. Okay? And it says that there's a rope attached to it, to the bow, which is right here on the very front of the boat, right there. It's attached to a pulley that happens to be 10 feet above the boat. Okay? So the pulley is 10 feet above, but it's also over here somewhere. So this is where the pulley would be. Okay? And it's attached to the boat like this. And the pulley is just, pulling that rope in. And it pulls the rope in, the boat's coming into the dock. Okay? And we know that this distance right here has to be 10 feet. And that is not changing. Okay? That pulley's 10 feet above it. What is changing, though, as the boat comes in, is this side and this side. Okay with that? So that's the picture. It's a right triangle. They're telling us that the rope is, let me see here, pulled in at a rate of 20 feet per minute. What is that? That's the rate of change of what? It's the rate of change of z. How do I write that? Yeah. We happen to know, and this is something we didn't do this on the last one, but you should go through and write down what all these things are. Now, is z getting bigger or smaller? It's getting smaller. So what do we know about this rate of change? It should be negative. Okay, they're not going to say negative 20 in the problem. They're going to say at 20, but it's getting smaller. Okay? Then they're also telling us at what rate will the boat be approaching the dock. Well, what are we looking for? What do they want us to find? The rate, not x. X is where it is, how far from the dock it is. We want the rate. So we want dx dt. That's our main goal here. We want to know what is dx dt going to be. Okay? And they're telling me when there's 125 feet of rope out. And that's z. Okay? So, very similar situation to what we did yesterday. We got a Pythagorean theorem going on here to link all these together. We know the rate of change of one side. We want the rate of change of the other side. So, we're going to say that x squared plus 10 squared, which is 100, has to be z squared. Okay? And we know z was 125. So this equation will allow me to find x, but we're not really interested in x right now. We want to find dx dt, so we got to derive it. So when we derive this thing, we get 2x times dx dt. The 100 just derives away to 0. And over here we're going to get 2z dz dt. Everybody okay with that? And then so now again, dz or dx dt is what we're looking for. We're not supposed to know that. We got to plug everything else in. So we know dz dt is negative 20. We know z is 125. And we know there's a 2 here. We're not supposed to know dx dt yet, which means the only thing we really have to find is what x is. Cool. And again, very similar, but we're missing one variable, so we got to find it somehow. And usually when that happens, you go back to your original equation before you derived it, and that will allow you to find what you're missing for. If it's not there, then go back and read the problem again and think, like, what information are they giving me to find this unknown variable? But we know that z is 125, so we know that x squared plus 100 has to be 125 squared. Okay with that? What's 125 squared? It's obviously 15,625, right? You guys don't know? They don't teach that to you? Come on now. Well, now you know. You gotta memorize that. When we subtract 100 and take the square root, we get that x is going to be the square root of 15,525. Okay, these are kind of big numbers. This might, you can do this without a calculator, but this will probably be a calculated question of some kind. Okay? So, we're going to plug that in for x. I'm going to give myself a little more room down here. We have the square root of 15,525 and the 2 there. So dx dt, when we simplify this down, is going to be, the 2's are going to cancel here because we're going to divide by 2 on both sides. And then we're going to have 125 times 20, which negative. So that's going to be negative 2,500, right? And that's over the square root of 15,525. Okay? And that's going to be in what units here? The units that the row's being pulled in was feet per minute. So this is going to be feet per minute also. So yeah, we should probably simplify this. So what goes into 15,525? Definitely that has a nice square root. 25 definitely does. Okay.